It allows graduates to go out and pursue careers in different avenues. The automation leads more to maintenance work or engineering assistance, where the electrical technology leads more to the trade area to include high voltage electrical work, instrumentation. So they have a big variety of jobs. Today, I'm here to talk to you about a special class that we actually teach there. It's called Fundamental Robotics, which is part of our automation section. Pretty much everybody should know what robots are. I basically teach the robotic arms that you'd see in factories. Vernon College is pretty excited because we got the new leading technology in robotics. It's called a cobot. Stands for collaborative robots. Robots traditionally are used in factories where they are used alone because of safety reasons. They're normally in a cage, where these interact with people. So before I start walking through the robot itself, we're going to show you a short video on the robot that we actually selected to use. And after that, we're actually going to go through the functions of the robot. You want to give me a 5 minute or something? And do you want me to leave time for questions? Okay, well, you actually saw that's definitely a sales pitch. We chose a robot called Universal. It's a growing robot out in the field of robotics. There is, as far as I know, this is the only one in Wichita Falls, including industry. Normally the ones in industry right now are industrial type robots that do not, once again, work with people. And you see some of the things that he's doing on there. And probably the first question you might ask, all it was basically screwing in screws. Why can't you just pick up a drill and actually do that? Well, you got to remember part of the reasons what robotics is used for. There's several different things. First one is to keep the workers safe. So if they're working in a dangerous situation, basically it frees them from any kind of being hurt by anything, such as heat or moving parts or so on. Also, the robot never gets tired. So it can work basically 7 days a week, 24 hours a day and never miss a beat. Whereas when you have a redundant job, is what you saw up on the screen, is mistakes can be made. So you do it for accuracy and repeatability. So the robot itself is a defined robot for industrial purposes. By that I mean there's an organization that basically defines what makes a good robot. And the one bullet statement you had up there is the 6-axis. If a robot wants to be fully functioning in a manufacturing setting, it has to have 6 axis, and that includes a base, and that allows the robot to go back and forth. We can actually show you. You can see the robot actually moving back and forth. Then it has a shoulder. The shoulder would be the second axis down here. Its job is to bring the robot in and out. The one before moved it side to side. Now it does look like it's going down, but that's the reason why it is going down, is because of to make up the structure of the robot. And then you have a Z-axis, or the elbow that goes up and down. Now the device I'm using is called a teach pendlet, and it's hand carried. It's got a strap in the back. It's got an emergency stop on it. And when the operator is actually operating a robot, they have to do this for safety. And with these robots, it's not so critical as it is with the larger robot that you'd see in my lab back at Vernon College, because this basically is not going to hurt you. The robot itself, that might be a little bit hard to do, is made with a whole bunch of sensors in the body of it. So if it comes in contact with anything, it's going to stop. See, it just stopped right there, and I'm still holding it down. So that's the way the robot works. So, so the other 3 axes would be what they call the orientation, the wrist action, is how you actually get down to your workpiece. This right here is going to be my workpiece, and it's just going to actually do a pickup. So you start off, then you have your wrist motion 1. As you can see, it moves it in and out. Then it's going to put it at an angle. And then it's going to rotate it. Now, one thing you noticed on the video, like most robots are only made to move less than 360 degrees, which is a little bit less than a circle, about 340, and that defines something called a workspace. So whenever you're designing and doing the engineering part of it, it has to be, one critical thing you have to look at is the robot's capability to reach. This is a very small robot. It only reaches out 23 inches, but it has big brothers that will reach out possibly out to 40 inches, and they got a new one that will reach out farther. But with this robot itself, you can actually work around it. So the teach pendlet itself basically helps you program the robot, move the robot, and declare any kind of faults that's actually accomplished during the process of actually doing a program. There's 2 different ways to move a robot. There's a joint movement and what they call a Cartesian. The joint movement means that each of the 6 axes I'm moving independently. So if I just want to move it back and forth independently, I'm just moving the base or the x-axis. If I want to move it in and out, I have to use, if I want to keep this height, I have to use a combination of the y-axis and then bring it back up with the z-axis. But you can see it's starting to reach out to its full length. And then you have your orientation. Now, once the orientation is established, and by that, I mean, if I have a part laying strictly on the floor or on this metal grate right here, we can say it's at 90 degrees to the surface. And the robot will help you align that with a button actually you can press here, down at the bottom. I know it might be a little bit hard to see right down here. So if it does get off a little bit on the x-axis, all I have to do is press this button here. And it'll line it back straight up. And this is very important because you don't want to be picking up your part or trying, as example you saw on the film, you don't want the screwdriver to actually be going in at an angle. So this is a very important thing for the operator to do. There's different type of, this is called an end deflector. In other words, what kind of tools at the end of the robot, and it has different type of toolings itself. That this is just a suction cup made to pick, it's called a pick and place process. In other words, it picks up the part and replaces it maybe on a conveyor belt. But you could actually have a welding torch on this. You can have a gluing process on it. You could have a buffing tool on it to buff the part out. Anything that you can actually imagine you can put on the end of this. So we just have a suction cup here. One thing you notice with the way the screw is turning in, this is This robot itself, the cobot, is designed to basically move more than 360 degrees, and you kind of saw that on the film. So if you go back to the very last, it's not moving very fast, but that's about as fast as it's going to move. Let me swing around to the camera. So with this, basically, you can do a constant turning motion. That's where they actually get the threading of the screws that you saw on the video clip. So to keep on going. This is a really good feature. Another feature of the cobot, instead of just doing the 340 degrees like I said, basically the base axis can actually do 2 revolutions. So that means it can go around twice. I don't know why you'd want to do that, but if you did have a process that worked all the way around the circle, the robot would be able to get there within the 23-inch we talked about. So this is a pneumatic, and once again, this inflector, this end tooling is pretty unique because it doesn't require an air compressor. It creates its own air. It has its own compressor in it. So if we actually wanted to test that out, we can actually hold a part for 30 seconds. And then it's going to release it because that's all it was designed to, is go up 30 seconds unless you're programming it. Once you go into program it, you can hold it forever. So this tool right here to teach pendulum we talked about becomes a very important part of the robot itself because it does everything. As you can notice, it's kind of really easy to handle because we've got a strap back here. And it has a black button. This is another very unique feature with the universal robot. It's called free drive. So normally you would have to actually be patient and move the robot from place to place in this slow way. With this, basically, it acts like a clutch and it releases the robot to allow you to move it wherever you want to. So if I wanted to move down here to save time, get as close to the work part I needed to, like so, and take my hand off the button, then I could actually put it in place. Reason that wasn't working, the robot was telling me I was moving it too fast. So we can actually line it. And like I said, the next thing we want to do is make sure that it's straight up and down. So it's this time, I think there's some questions. So let's go ahead and take some questions.
What type of education and training is needed to enter this career field?
Normally an associate's degree. It's not a full-fledged engineering degree that you have to spend 4 years at. It's going to be a program just like my program where students learn. This is a small part of the technology we learn in automation. The definition of automation is making sure that the process runs automatically and it corrects itself. So robotics is a big part of that, but it's just a minute. So to answer your question, a certificate or associate's degree would benefit you a lot in this field here.
What is the entry-level pay, the max pay that you can make?
I have students starting out in the low 40s, and then I have students making $90,000 a year. Normally with the maintenance positions, you're going to be somewhere between $50,000, $60,000 a year. That would probably include being an engineer assistant or a technician. But on the electrical side, we see higher wages up to 85 to 90. I do have one graduate that's making about 90,000 as a lead automation technician. He's basically performing a job as an engineer, but he's really smart.
What is the worst part about this job?
I haven't found a worst part about it, but sometimes the maintenance workers that work at the factories go into shift work. That means they work from 7 o'clock at night to 7 in the morning. So you're in a factory without walls, without windows. So, that might be the worst thing. Like I said, that's a really good question because most people just kind of look at the pay. But if you go on the electrical side, basically you're working a 9 to 5. You could be working overtime whenever it requires because of emergency. So I'd have to say the worst thing is when you go into maintenance, you're kind of at the mercy of the scheduling.
You ever had an accident at your someone injured?
No, we take a lot of safety precautions. Most of the robots are geared down. In other words, they're training robots. I got 2 full-fledged industrial robots that will move, and they'll move at 55 miles per hour. So we basically put limits on the speed to protect the students, and they're always within eye reach from the instructor.
How smart do you have to be to do this job?
That's what they pay us the big bucks for, it is to make you smart. So I've got students with every type of skill set you can imagine. If you want to get a head start on being a little smart, a lot of the robots are made by foreign companies, so they use a metric system when you're measuring things. If you looked at the, you can't see it on here, but if you looked at all the commands on here, they're in millimeters. So you have to be able to, if you don't have a smartphone on you, you have to be able to do conversions from the good old American standard system called an empirical over to the metric. But as far as being smart, I've had all students from walk of life, from 18-year-olds up to 50-year-olds, and they all get the job done.
Have you ever built a full robot?
No, there are courses out there where you build more of the car type robots. They do it up in our computer information science. When they're learning how to code, they will build a robot from the ground up. They're little small kits, but that's really not our mission, what we want to do there. Our students, when they go through robotics, need to know how to move the robot, how to program that robot, and very, very light repairs, such as clearing faults. Got time for one more question, or are we done?
How much would a robot cost if you were to make one and sell one?
Okay, this robot right here costs $30,000. The most expensive one I have in my lab is $65,000. So I refer to them as my cars. So this is my Dodge Challenger, the 6-cylinder one. So, and then I've got it all the way up to a BMW in my shop. So they're not cheap, they're very expensive, but what the manufacturing side does is they look at something called a return on investment. The thing about cobots, normally the return on investments are probably within a year or two, where a full-size robot is going to be somewhere between 3 and 5. So, well, I think we're going to be out of time, so I just want to close that. Vernon College has a lot of good workforce programs out there. You don't have to go to a 4-year degree to make great money. I've got plenty of students out there making good money. Not only that, they love their jobs when they go to work, especially when they're working on something like this all day long. They feel like they have a purpose. It's a good alternative. So when you guys get out of high school, and I know you're probably not thinking about being a senior yet, but time flies. And as you guys enter into your freshman year next year, you're going to have to start making decisions on where you want to do. And where we have a hole at in career and technology training is the students coming straight out of high school. Seems like on all of our programs, we get to 25s, the 30s, and 35-year-old people, but we don't get to 18. So we need to get you guys right back into a program after you graduate. We're always open to coming out, looking at our equipment, talk about the programs, no matter what your age is. We got a really enthusiastic recruiter, and she'd be more than happy to help us. So we're not hard to get a hold of. Just call out the Vernon College and ask for help, and we'll give it to you.